Last episode, we saw that it was the observation of Hubble that led to the birth of this idea of the Big Bang Theory. As it turns out, there are many other independent observations that really convinced physicists that this theory had to be true. The next major evidence for this theory is the cosmic microwave background, or the CMB. In 1964, the cosmic microwave background was discovered just by accident. While observing the sky, a strange static was received that was in a microwave band. Even though all the electrical noise was cleared, this static persisted. What was even more confusing is that this static was received in all directions despite changing the orientation and location of the telescope. So it probably meant the telescope was faulty, right? No, this was radiation being received from the sky. To understand this, we need to take a look at the black body spectrum, and this detour should be worth it. Let us accept the fact that visible light is only a tiny part of the electromagnetic spectrum, and we must prevent limiting ourselves to only what we see, that is 400 to 700 nanometers of wavelength. We mentioned earlier that light is a wave, and it is therefore natural to conclude that its energy depends upon its amplitude. But one of the most important insights in physics in the early 20th century is that the energy of light actually depended on the frequency and not its amplitude. This relationship is described by E is equal to hf, where E is energy, h is the Planck's constant, which is again defined as E by f, and f is frequency. But what is this energy of light? Heat. Heat is light. It is true that all light that we see originates from vibrating electrons or electrically charged objects, and it is heat which excites these electrons in the first place. We have heard that infrared radiation is heat, and while this statement is not false, it kind of conveys that microwave, radio, UV, gamma or visible radiation isn't, which is totally not true. So why is it that we can see light and not heat? That's because the temperatures that we experience on our earth are too low to glow in visible light. They mostly glow in infrared. If you heat an object beyond 1200 Kelvin, it starts glowing red. Heat it further, it will glow white, then blue, and then UV, which is invisible again. This relationship between temperature and brightnesses of all different wavelengths of light emitted by an object at a certain temperature is described by the black body spectrum. The black body spectrum for an object at 2.7 Kelvin, which is the temperature of empty space, is mostly in the microwave band, and this curve exactly matches the CMB. Let us go back in time to see why this phenomenon is an evidence for the Big Bang Theory. If the Big Bang Theory is right, then the universe was much smaller and denser and hotter before than today. When the universe was about 380,000 years old, then it was so hot and dense that atoms couldn't form. The entire universe was made of plasma. Electrons could freely zoom in the hot dense soup of matter. The universe was opaque, and at this time light couldn't travel for long without bumping into electrons and scattering of them. Then the universe cooled a bit. The universe was expanding, and this caused the plasma to thin out, and light being emitted by them got redshifted. This itself caused the universe to cool down in the first place. Longer wavelength of light means less energy, remember? The universe kept cooling down until it reached the exact temperature at which atoms could form. But just before it did, it was like one final flash that was emitted before the universe became transparent, and this light could freely zoom through the expanding universe. This light over the past 13.8 billion years got cosmologically redshifted from the visible spectrum to infrared and then to the microwave band. And that is why the temperature of space is 2.7 Kelvin, and that is why it matches the CMB exactly.